Hello everyone, welcome to the Engineering, Computation and Instrumentation 5th lab. Today we will know how we can deal with two-dimensional arrays and nested for loops. In this lab, you are required to submit pseudocode instead of writing flowchart. Pseudocode in general is similar to code but is written in English. There are many ways or styles that pseudocode may be written. But the most important factor that determine if your pseudocode is good or not is how clearly it describes what needs to be coded. If anyone can easily understand your pseudocode such that he or she could implement it in code, then your pseudocode is good. In this pre-lab submission, you have to write pseudocode for the code that you write only. Don't write pseudocode for the starter code given to you in Vocarium. You may produce your pseudocode on computer and print it, or you can submit it by writing it on a piece of paper. Now, let's talk about what is required from you in Lab 5. We will implement a very simple interpolation algorithm in this lab. Each interpolated value will simply be the arithmetic mean of the closest values around it. So each interpolated value will be the average of the closest values around it. Consider a 4x4 square matrix of numbers as represented in this figure. We wish to interpolate between each pair of numbers both horizontally and vertically such that the result is 7x7 matrix as shown in this figure. How can we do this? You are given starter code in the Vocarium. As a general note for you, please don't change or delete any of the starter code. Okay, so you are committed to follow this starter code. In this starter code, we start by using hash include input output stream, as we will use the cin and cout object, and after that hash include input output manipulator, as we will make some output formatting, and after that we start our code by declaring or defining our variables. We define our variable I and j, as we will use them as counters for the rows and the columns, and after that we define row underscore counter that we will use to define the row number, and after that we declare integer num of rows and num of columns that represent the size or the dimension of the original matrix, and after that we declare integer of rows and integer of columns that define the dimensions of the new interpolated matrix. Then we will ask the user to enter the number of rows and columns in the square data matrix, and we give a hint for the user that the dimensions of your matrix must be greater than 2x2. After that, we will read the values that the user will enter, and these values will represent the dimension of the original matrix. After that, we will calculate the dimensions of our new interpolated matrix, as you see in these two lines, and after that, we declare our two-dimensional array grid whose size will equal to the size of our new interpolated matrix. The value of each element in this two-dimensional array will equal to the value of 1 point in our matrix. Then we will read the original matrix values into their positions in interpolated matrix. Here, in order to be able to read the value of each point in our original matrix, we must use the nested for loop. One for loop for rows and the second for loop to the column. So we will start with for I equal to 0. So we set the counter I to equal 0 to represent the first row in our matrix, and then we will check our condition if I is less than rows. If this condition is satisfied, we will print out enter the data of row underscore counter, and we set the initial value of this variable to be 1. So we will print out enter the data of row 1. After that, we will enter to the for loop of the columns. So we have for j equal to 0 to represent the first column in our matrix, and then we will check our condition if j less than columns. If this condition is satisfied, or if this condition is true, we will read the value of grade of 0 and 0, which represent the value of point 0 and 0. Okay. After that, we will increment the value of j by 2. And the reason that we increment the value of j by 2, as you see here in our new interpolated matrix, the original points in our matrix are separated by 2 here, 0, 1, 2 in rows and also in columns. So here this is in columns, sorry, 0, 1, 2, and in rows also 0, 1, 2. This is why we increment the value of j and I by 2. After that, after we increment the value of j by 2, we will check our condition again if j equal to less than columns, and if this condition is true, we will enter the value of point 0 and 2, and we will repeat this repetition so on until this condition will be not satisfied. So we will exit this for loop, and after that we increment the value of row underscore counter here to represent the row number 2, and return back to increment the value of I by 2, and then check this condition. If this condition is satisfied, we will again enter the data of row number 2 as we increment its value, and after that we will enter the for loop of to manage the value of our column, and we start with j equal to 0 and check if this condition j less than columns is satisfied, and after that we will enter the value of point 2 of 0, okay, and then we will increment the value of j by 2 and return back to check this condition, and after that we will enter the value of point 2 by 2, and we will repeat this repetition until this condition will be not satisfied, and after that we will increment the value of row underscore counter to be 3 and return back to increment the value of I plus by 2, okay, and check this condition. If this condition is satisfied, we will repeat the execution of our code. If this condition is not satisfied, we will exit from this for loop. By the end of this nested for loop, we will be able to enter all the values of all points of our original matrix in their new positions in interpolated matrix. After that, we will print out on the screen. This program will interpolate our original matrix that the user will enter its dimension to a new interpolated matrix with new dimensions here. Okay. Now we have the values of points of our original matrix, and these values are now in new positions in interpolated matrix. What we want to do now is to get or to calculate the values of the new interpolated points. We can do this by following 3 steps. At first, consider that we have our original matrix size or dimension was 4 by 4. So based on these equations, the dimension of our new interpolated matrix will be 7 by 7. So we have our rows will be from 0, 1, 2, 3, 4, 5, 6, and our columns will be from 0, 1, 2, 3, 4, 5, 6. Okay, so the dimension of our new interpolated matrix will be 7 by 7. So our first step is to interpolate the points in the center of the square. So we will set points in row 1, 3, 5, and in columns 1, 3, 5. And the value of this new interpolated point will be the average of the sum of the values of points around it. So if, for example, if this point in row I and column j, so its value will be the sum of the value of this point in row I minus 1 and column j minus 1 plus this point which is in row I minus 1 column j plus 1, and this point which is in row I plus 1 column j plus 1, and this point which is in row I plus 1 column j minus 1, and in order to get the average we will divide this summation process by 4, so we now can calculate the value of all these new interpolated points. In order to implement this line in our vocarium, so we can use the nested for loop as we used before. We will use one for loop for rows and the second for loop for columns, and as you see here we start I to equal 1 as the first row of this new interpolated points will start from row equal 1, and our condition will be from I less than row minus 1, as the last row of these points is equal to row minus 1, and we increment by 2 as you see here. Okay, the same for the columns. We start from column 1, and our condition will be if j less than columns minus 1, as the last column for these points is equal to column minus 1, and we increment between columns by 2 as you see here. After that, we can calculate the value of point ij using these equations by taking the average of the sum of the points around it. Okay, so this is our first step. The second step is to interpolate the points in the center of a cross, something like that. So we interpolate new points in row 1, 3, 5, and in columns 2 and 4. So in order to be able to calculate the value of these new interpolated points, we calculate the average of points around it. So let us consider this. The position of this point is in row I and column j. So the value of this point will be the value of point I minus 1 j and point plus point I j plus 1 plus point I plus 1 j plus the value of point I j minus 1, and we divide by 4 to be able to calculate the average of this summation. We also want or need to interpolate new points, and like what we did here. So we need to interpolate new points in row 2 and row 4, and in column 1, 3, and 5. And following the same way, we can calculate the average of these new points by taking the average of the points around it. So again, if we consider this point to be at position I and j, so the value of this point will be the value of the point I minus 1 j plus the value of point I j plus 1 plus point I plus 1 j plus point I j minus 1, and we divide by 4 to be able to calculate the average. In step 4, we need to interpolate points in the top row. So in this case, we fix our row to be row of 0, and we we change the location of these points by columns. So we need to interpolate new points in row 0 and column 1, 3, and 5. And we can calculate the value of these points by taking the average of the point around it. So we have here, in this case, only 3 points. This point, and this one, and this one. And again, we can, in order to be able to generate our new interpolated matrix, we need to interpolate new points in the most left-hand column. So in this case, we fix our column to be 0, and we change the position of our points based on rows. So we interpolate new points in column 0 and in row 1, 3, and 5. And again, we can calculate the value of this point by taking the average of the points around it. So in this case, we have only 3 points, this point, and this one, and this one. And finally, we need also to interpolate points in the most right-hand column. So we fix our column to be the value of column, the maximum number of column, and we change the location of the points by rows. We interpolate new points at column equal to column, and we change rows. We interpolate new points in rows 1, 3, and 5. And again, we can calculate the value of this point by taking the average of the points around it, which here in this case is only 3 points, this point, and this one, and this one. And in our last step, we can interpolate new points in the bottom row. So we fix our row to the value of rows, and we change the value of our column. So we interpolate new points in row equal row, and in columns 1, 3, and 5. And again, we can calculate the value of this point by taking the average of the points around it. we have here 3 points, this one and this one and this one. So at the end of your code, you are given in your starter code a code to display the value of each element or each point inside our new interpolated point, and you can test your code to verify that if your code is correct or if you have any errors. So you can use the examples given to you in your lab manual. I hope everything is clear for you. Thank you.